question that I frequently get is, we heard about this on the panel as well, is whatever extreme event that has just happened or is happening now, or even this summer, I got the question, is this extreme event that is forecast to happen this weekend due to global warming? And so we are literally being asked before the event happens whether or not it was caused by global warming. About half of the carbon dioxide that humans have emitted has stayed in the atmosphere. About a quarter has gone into the ocean, and the other quarter has gone into land. And we're seeing very clearly, again, just through measurement, that not only is the partial pressure of CO2 going up in the surface ocean, which you see in the blue, but the pH is going down as would be expected. So the ocean is getting more acidic. So we're altering the chemical composition of the atmosphere and the oceans. Right there, so 2017 was the second warmest year on record, second only to 2016, right? Then 2016 broke 2015's record. 2017 came in above 2015 and below 2016. 2017 is not only the second warmest year on record, it's the warmest non-El Nino year that we've ever had. Right? So global temperature is rising. Global warming is a measurement, right? It's not a matter of politics. It's not a matter of belief. Right? If you believe in thermometers, then you have no choice but to believe in global warming. It's just what the thermometers record. Okay? 2017, more than $300 billion in damages from these events here in the United States. Most expensive year on record. But we do know from, again, about a decade of research that lots of different kinds of extremes are increasing. We know that in the US, severe heat is increasing, like you saw in that figure. Heavy rainfall is increasing. Extreme storm surge flooding is increasing. And these are the long-term trends, right? But what we've also seen is a lot of different scientists trying to understand these individual events. So not just the trends in the tails of the distribution, but actually analyzing individual events. We also know that the sea level rise that's already happened increased the probability of the storm surge flooding that happened in Sandy, right? So just for exactly the same storm making landfall at exactly the same time of year with exactly the same track, that storm caused more flooding in New York than it would have without that sea level rise. Starting with the California drought. So this was a severe event. It was severe for the state's economy. It was severe for jobs. It had a big impact on jobs in the state. Killed on the order of 100 million trees in the state, and we're still feeling the effects of that with these wildfire seasons. There are communities in the Central Valley that are still feeling the effects of the drought in terms of their access to water. Communities that went a couple of years without running water. So this was a severe event, and California has really been proactive in integrating, engaging with scientists and engineers and legal scholars, and integrating the best understanding into real-time decisions, and have taken us at our word, and then integrate that information into decisions. Okay, so the risk that low precipitation ends up producing drought is twice as high, in fact, a little bit more than twice as high, if it's also warm along with low precipitation. The number of low precipitation years hasn't changed, but the fraction of those low precipitation years that are also warm has doubled. The fraction of those low precipitation years that produce drought has doubled, and the percentage of years that are drought years has doubled. Right? So imagine if you have two coins and they're both 50-50. At the time that California's infrastructure was built and that we made all our rules for how water is let out of dams, right? We basically got half warm years, half cool years, half wet years, half dry years, basically like flipping two coins. But this warming of California has made it so that now we've got this temperature coin that's coming up tails over and over again, right? We've got an 80% Temperature coins. If I tell you I've got one coin that comes up tails 50% of the time and one that comes up tails 80% of the time, you think you're going to get more tails plus tails? Right? It's as simple as that. So I was in 8th grade in 1988 when this figure was published in Discover magazine. So Andy Revkin posted this after our paper came out. So, that looks familiar. Right? So Peter Glick was saying, 30 years ago, literally, this is what's going to happen. Right? So the only real update to what Peter said 30 years ago is that he said 2050. Now we're 2018. Right? We have very steep trends towards exactly what was predicted 3 decades ago. Right? So you talk about new normal. This is beyond new normal. This is like an entirely new statistical distribution. Right? We don't. The highest Arctic sea ice year is still lower than what used to be the lowest sea ice year. And this is truly phenomenal from a statistical point of view. Like I play basketball. I just pick up basketball on campus. I'm not very good, but I run around. I can't dunk at all. Like 0 dunks. 0. No dunks. No career dunks. If the floor was just 10% higher, I would dunk a lot. Like literally, I don't need a 2-foot basket to dunk. Like if it went from 10 feet to 9 feet, just a 10% raising of the floor, 10% decrease in the height of the basket, I would be dunking, it'd be normal. It'd be the new normal. I would just be dunking. I wouldn't dunk every time. Wouldn't always dunk. But it would not be a big thing. And that's the point about, right, these changes tip the scales, right? And when we're looking at thresholds, right, you get a lot more flooding with this sea level rise for the same storm. The question is not, would there have been no hurricane without global warming? That's not the question that we're asking, nor is it the appropriate question, right? The variability always plays a role, as I said. But global warming's tipped the scales. You take 9 billion people consuming that highest efficiency economically developed country, and that's about a 4-fold increase in total global energy supply. Right? So the reality is the world's going to have to supply a lot more energy than we do now, a lot more equitably than we do now. The other reality is that in order to meet the Paris goals, right, so to stay below 2 degrees C, we will have to decarbonize the energy system by mid-century. And even that assumes that we get some negative emissions after that. But back to the envelope, decarbonize the energy system by 2050. Meeting the Paris goals is going to require a massive transformation of the global energy system.